Math 1, we are in the 1.3, 1.4 formative. Our video ended a little abruptly. I was having some technology problems, but let's pick back up with problem number 6. It says an Instagram account starts with 10 subscribers, and each day, wow, that word each is going to tell us our input. It sure looks like we're going to have day or days as our input. We could even write day, but it sure looks like we are dealing with the number of subscribers. That's what we're measuring for our output. So, that's going to start us off. And it says it starts, that means we will have times 0. Our input would be in days, so that would be 0. We start off with 10 subscribers. But each day, the number of subscribers doubles. So on day 1, doubling means multiply by 2. We're going to have 20. On day 2, 20 times 2 is going to get you 40. On day 3, and you get the idea, 40 times 2 is going to get you 80. Day 4, we're going to continue to multiply by 2. We'll be at 160. And, obviously as we're, moving on here, we could say, as we continue, here's day 5, that would be up to 320. Day 6 would be up at 640 if you were to continue to double. So we've really traced this out, filled in our table. Remember, our input is X, so we're going to have the number of days right here, and we'll have 0, 1, 2, 3, 4, 5, 6. And then here, for our Y scale, we're going to have number of subscribers. But we have to be careful. Again, it looks like we've got, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines. And, as we're looking at this, we need to be able to have a scale go roughly up to 640. So obviously we have to really increase by quite a bit, don't we? So, as we're thinking about this, we can really begin to wonder what kind of a step equally spacing will allow us to get up there. Well, we've got 12. If we went by, 10, 10 times 12, well, that's way too small. That's 120. If we went it by 100, that would also help us get there, wouldn't it? So there are many different scales that we can have, but as I'm looking at these numbers, I'm seeing that quite a few of them are multiples of 8. So I'm going to actually go by 80s. So this would be, an 80 times 2 is 160. Here's a 240. 80 times 4 would be 320. This would be 400. So there's more than one correct way to do this, but you must keep the same spacing. So again, this might be a little bit nicer. Just paying attention to these numbers can be very, very helpful. Well, 0, 10, that's going to be very, very low. That's going to be down here. 1, 20 is just going to be a little bit higher. At 2, 40, we're going to be pretty much there midway. And then finally, 3, 80 will be right here. 4, 160 is going to be right up this way. 5, 320 is going to be up here. And then 6, 640 is going to be all the way up here. So you can definitely see the curve taking place. What type of sequence? The sequence is geometric. Because the pattern is multiply by 2 each time. And you really want to include the each time to be able to truly communicate why you know this is true. Doubling, of course, is going to mean that you are, in fact, multiplying. So real quickly, let's jump over here to number 7. It says, on day 1 of a sports tournament, there are 120 teams. Well, here is a very friendly phrase. The word each very, very frequently will tell you what your input is. So, we know we're going to have a day. By the way, you can have your X label for your graph labeled immediately. But what are we really measuring? Well, we're measuring teams. So we can say the number of teams is something that we've got right here. It says on day one, there are 120 teams. So each day there are half as many teams. So half means that you're really just multiplying by 1/2. And by the way, before we forget, let's label our graph also. Labels are so very, very important for tables and for graphs. Multiplying by 1/2 is the same thing as dividing by 2. Taking half of something. And half of 60, well, we're going to get 30 right here. Multiplying by 1/2, taking half of 30, well, that would be 15. On day 5, you take half of that, you'd be at 7.5. And, you clearly can't have 7.5 teams. This is really just giving us a model as to what we would expect. Obviously, you need a whole number of teams in real life. But if you divide 7.5 by 2, you'd be at 3.75. And then finally, if you were to divide this one by 2, you'd have 1.875. So I'm going to start scaling. Looks like we're going to go 1, 2, 3. Here's a 4, 5, 6, and a 7. Now, getting as high as 120, we've got 12 lines. I'd suggest that we count by tens. And the scale is so very, very important, guys. It must be equally spaced. And again, there's generally more than one way to scale. It's just that I'm seeing, especially as the numbers are larger, in the beginning especially, they're multiples of 10. And here's 120 at the top. So on day 1, we're all the way up here at 120. Day 2, we're here at 60. Day 3, we're here at 30. Day 4, we're at 15. So we're going to have to go in between the 10 and the 20. And then we're going to see a drop. 7.5 would be about right here. 3.75 is quite a bit lower. 7 is going to be way down here. What are you seeing, though? You see a curve. What type of sequence is this? You could say the sequence is geometric. And we can think about why. We have to say why. Well, because the pattern now you can say one of two things. You could say is divide by 2, or you could say is to multiply by 1/2 each time. All right. So as we move on to number 8, very, very, different type of a problem it appears as we've got a loan. In the first week of school, your uncle gives you a loan. You will pay him back $10 a week. You could even say it's going to be each week. So we can say, here's your week, and a loan is how much you owe. You could also write loan amount. But in week 1, you owe $80, right? You're going to pay back $10 a week. So you give your uncle $10, you subtract, now you owe him just $70. On week 3, well, you subtract a 10, you're going to be at 60, and you'll be at 50, then you're going to be at 40. You get the idea. Each week, what you're seeing here, and pardon me, I actually need to erase this. That's week 6 and week 7. This is going to be down to 20, because each time you're going to subtract a 10. Okay, we got a label. We're going to have down here would be the week that you have. And over here you have money owed in your loan. So we can say this is a 1, this is a 2, 3, 4, 5, and a 6, and a 7. And again, for what you are owing, if you want to go by tens, you certainly may. There are other ways you can do that, of course. You have some choices. But it looks like everything is ending in a 0. They're all multiples of 10. So you may certainly make use of that. So 1, 80 is up here. 2, 70 is right here. 3, 60. 4, 50. 5, 40. 6, 30. And 7, 20. You can definitely see this line. You can see I have not connected it. But what type of sequence is it? You could say the sequence is arithmetic, because the pattern is subtract 10 each time. So anytime you're adding or subtracting, you're going to have something arithmetic. Okay? So as we take a look just at this ending here at number 9 and number 10, we first want to name whether we have a common difference or a common ratio, but then we need to explain the meaning. So let's read this together. It says, Lorena's TikTok video has 100 views the first day, 300 views on the second day, 900 views on the third day. You can see, really, if you wanted to, you can even begin to make a table. You could say on day 1, she's at 100. On day 2, she's at 300. Day 3, she's up to 900. And what pattern are we seeing? I hope you can agree. The pattern is multiply by 3, right? So we're going to have a common ratio. This is geometric. Notice that the value that I'm writing is 3. I don't put a times in front. But to explain the meaning, we have to talk about 3 things. We have to talk about what we are measuring. We have to talk about how much it's changing, or how it is changing, and then also how often. So explain the meaning. The meaning, I should say. We could say the number of views. That's what we are measuring. We always start with that. We could say triples, if you'd like, or multiplies by 3. So you could say triples. But then how often? We can say each, well, it's each day. Okay? Finally, on this slide 3, it says a Manies Club has 8 students the first week, 13 students the second week, 18 students the third week. So time generally is your input. So we've got students is what we are counting, what we're measuring. And what are we seeing? We had week 1, there were 8 kids. Week 2, we've got 13. Week 3, we've got 18. And I hope you can see we're adding 5. So this is a common difference. The common difference is the number that we add or subtract. And then we have to explain the meeting. We're going to say what we are counting or measuring. Well, that's the number of students. So we can say the number of students. Now, the addition means it's increasing. So we can say increases by 5 each week. So remember, we need to talk about what we are measuring. That's the first part right here. How it's changing. This is where we're going to describe in math what number is changing and how. The increase means addition. And then how often. So that's your threefold sentence. You need to address all 3. We're going to wrap up this video and have a final one for slide 4.